So let us now introduce the government in this computable general equilibrium model in order to get a third type of models, and this model will be more realistic because of this introductions of a government that will be designed right now through a very simple way. So in fact, we will not address a certain number of problems. We will only consider two aspects of the presence of a government in this model. First, through public revenues, and second, through public expenditures. Concerning public revenues, in fact, there are many types of public revenues. So we can have direct taxations, indirect taxations, import duties, export taxes, and of course receipts from the sale of public services. So what we are going to do here is only direct and indirect taxations, and through a very simple way. Second, concerning public expenditure, again there are many types in real life of public expenditure: demand of goods and services, subsidies, transfer to households, interest payments, and many other things. And so here we will only consider the demand of goods and services. So let's start with public revenues, and in particular with direct taxation. So we have, of course, first to define the type of direct taxation that we want to introduce in this model. Then we have to understand the implication of this tax system on the economic agent who is taxed. And then we have to understand the impact on government revenues. So, of course, these three elements have to be consistent. So first, let's make things simple, and let's start with direct taxations only on households with a flat tax. ITR is the rate of the taxation. So it means that every household is taxed with this single flat tax. Then we have to understand the implications on the people who are taxed. So this is households. Households have got income from the ownership of productive factors, INC. So now there is a difference between what they receive from the productive factors, INC, and what they can affect to consumption or savings, but until now there is no saving in the model. So we make these distinctions by defining a new variable, which is called disp underscore INC, which means disposable income. And so it means that this disposable income is equal to 1 minus ITR, the rate of taxation, multiplied by INC. And so it means that it affects government revenues by increasing these government revenues by an amount which is defined by ITR multiplied by INC. So let's now consider the indirect taxation system that we want to introduce in the model. So here again we make things simple by considering the indirect taxation system under a unique rate, which we call indirect underscore tax, and which can be different from one sector to the other. So with indirect taxation, it means that there is now a producer price that we call PY, which is specific to each sector, and a consumer price which is called P. And again, it is specific to each sector. And so it means that we have to understand the difference between production price and consumption price, and we have to understand the implication on government's revenue. Of course, we have in each equations where there is a price, we have to understand if it is a production price or a consumption price. But here we have, in order for this model to be consistent, we have the relationship between production price and consumption price, which is defined by the relation Py in sector I multiplied by 1 plus indirect underscore tax in sector I is equal to the consumption price. Okay, so it means that when there is a positive indirect tax, it means that the consumption price is higher than the production price. And it means that the public revenues is increased by an amount which is the rate of taxation in each sector multiplied by the production price multiplied by the production. So what about the public expenditure? We make here a very simple assumption, which is that the government has Cobb-Douglas preference. So it means that the distributions of public expenditure amongst each sector is constant in value. So in terms of equations, it means that consumption price Pi multiplied by a new variable, which is public expenditure in sector I, CGI, in volume, is equal to a constant share, which I call alpha underscore G, in sector I multiplied by total expenditure, which is another new variable, which is budge underscore exp. What about the public accounts? In fact, we have public expenditure, which is budge exp, and public revenue, which consists in two sources of revenue. First, indirect taxation in each sector. So we have to sum these indirect taxations over I, which is sector, and we have direct taxations, which consist in flat tax rate ITR applied to the household income, which is INC. So in terms of deficit or surplus, well, there cannot be any deficit or surplus, and the reason is that until now we do not have any disequilibrium in the account of each agent. There is no saving from household. There is no needs for funds from firms. There is no demand for funds or supply of funds from the rest of the world. So it means that the government have to be the government's finance has to be in equilibrium. So there is a public balance, which means that indirect taxations plus direct taxations is equal to total budget expenditure. This is an equation that has to be inserted in the model. Let me right now present the whole third general equilibrium model with three goods and with the public agent. So we have 80 equations, generic equations, and we have one restrictions, which is W is equal to 1, which means that the remunerations of labor is selected as the numeraire. So we have a first block, which is the price block, which is the definitions of the relations between producer price and consumer price. We have then three blocks, which are production blocks. First about total production, which is a Leontief of value added and total intermediate consumptions IC. Another block, which is the second level value added, which means that value added is a Cobb-Douglas of demand for capital and demand for labor. Then we have a block which is the Leontief of total intermediate consumptions between intermediate consumption of each good by each sector. This is something that we had in the previous model, and then we have a fifth block, which is the income block, which is first definitions of households income, gross income, which comes from the ownerships of productive factors. And then we have equation 11, which is the definitions of disposable income, which differs from the gross income because there is direct taxation. And then we have a sixth block, which is the final consumption block, which define the level of utility attained by the representative household, which has Cobb-Douglas preferences. So it is U, the utility, and then we have equation 13, which is the definitions of final consumption of this representative household in each sector, agriculture, industry, services. So you take notice that this equation doesn't include INC, but disposable INC, because there is income taxation. And then you have a block which is the public agent block, financial block, with equation 14, which is public balance. Indirect taxations plus direct taxations is equal to total budget expenditure. And then you have equation 15, which defines, in fact, the demand of the public agent in each sector, CGI. And so it means that it is a constant share in value of total budget expenditure because government has Cobb-Douglas preferences. And then you have a eighth block, which consists in the market equilibrium block. First for good I, so it's equation 16, where you take notice that there is a new demand from the public agent, CGI. Then you have the labor market equilibrium with, in fact, the Léon variable, because you have still the Walras's law which holds, and then you have capital market equilibrium. You understand that there is 18 generic equation, and you have, in fact, 18 generic variable: producer price PY, consumer price P, value added VA, production in volume Y, total intermediate consumption IC, composite price of value added PVA, composite price of total intermediate consumption PIC, demand for capital KD, demand for labor LD, R, which is the remunerations of labor, CIJ, which is intermediate consumptions of good I by sector J, INC, which is gross household income, disposable income, DISP, INC, U, which is the level of utility attained by the representative agent, final consumption of this agent in sector I, this is C, budget expenditure, which is total public expenditure, CGI, which is the demand for good I by the public agent in volume, and then you have the Léon variable. So you have 18 generic variable. If you take into account the fact that there are 3 sectors, agriculture, industry, and services, it implies that you have 48 equations and 48 variables.